Okay, this is the second video I'm doing on the triangle inequality. In the first video, I just went through what the theory is about, what it says. Again, what it tells us is that if you have two sides of the triangle, the third side has to be somewhere between the difference of the two sides, subtracting one from the other, and the sum of the two sides, adding the two sides together. So here's an example. Triangle ABC, AB equals 10, and BC equals 13. What is the longest AC could be? What is the shortest it could be? And I put here, draw a picture, because I think that's always a good idea if you don't have a picture. Well, the longest it could be, we saw in the examples before that the longest it could be is if these two segments, AB and BC, were going in almost opposite directions. Remember, they can't be going in completely the opposite direction, because then I won't have a triangle anymore. So here's C and B, right? A, B, that's a C. It doesn't look like a C, but it is. All right, BC is 13, AB is 10. The third side is going to be something like this, okay? Then I have, that's like getting to be my longer triangle. Now my shortest triangle is going to be something like this. I can get this angle to be almost 180. It's got to be less than 180, but it can be almost 180. And if I did that, this side is going to be getting closer and closer to 10 plus 13. It's never going to quite get there, but it's going to be almost the sum. So that's going to say it's going to be less than 23. But it's going to be getting closer and closer the bigger I make it. Down here, if I make this angle very small, right, here's B, here's A, here's C, right, as these two get closer and closer together, then the length of this is going to get shorter and shorter, and it's going to get closer and closer to that case where they're just on top of each other, in which case AC is just going to be 13 minus 10. It's never going to get there, because once AB comes down to rest on top of AC, I don't have a triangle anymore. So AC, it's going to get closer and closer to 3, but it's never going to get there, so it's going to have to be greater than 3. So I can express that now by saying that AC is going to have to be less than 23. It's going to be greater than 3. And there's my inequality. All right, another example. Triangle PQR, PQ is 17, and PR is 12. What are the range of possible values for QR expressed in inequality? So I'm trying to, figure out again what that triangle is going to look like. It's going to be something like this. I've got P, Q, R, PQ is 17, PQ is 12, and here's going to be my third side. Well, the biggest it's going to be, if we think about that hinge again, is if I pulled it all the way here, so it's almost 180 degrees, right? It's going to be, so here's my R, or QR. It's going to be almost 29, 17 plus 12, 29. Then if I bring it the other direction, down here, it's going to get, that third side is going to get smaller and smaller, so it gets closer to 17 minus 12, or 5. So I've got 17 plus 12 equals 29. 17 minus 12 equals 5. And QR's got to be between those two, between 5 and 29. Remember, it can't be 5. If it was 5, then it's only going to be 5 when R is all the way down on PQ, and I no longer have a triangle. And it's not going to be 29. That would be when R is all the way over here, and I've got a 180 degree angle, and R, P, and Q are all collinear. It's going to be somewhere between 5 and 29. All right. Last kind of example. Could the following three numbers be the lengths of the sides of a triangle? Well, all we need to do here is figure out if each side is in between the sum and the difference of the other two sides. Now, an easier way to do this problem is to just pick the longest side, say 13, and ask yourself, is 13 between the sum and the difference of the other two sides? Well, the difference, that's 7 minus 5, which equals 2. Then we've got the sum, and so that's going to be the shortest that third side can be. The sum is going to be 7 plus 5, which equals 12, and that's the longest the third side could be. So, 13, is it greater than 2? Yes. Is it less than 12? No. So, 13 is too long, right? And think of it as a picture. If I had a side that was 5, like this side, and I had a side that was 7, this side, well, the third side couldn't be 13 because even if I laid them out next to each other, which we already saw was the longest we could make this whole segment, it's only 12, right? So 13 is way too long. Do the same thing with B. I'm going to take my longest side is 22, and then I'm going to subtract 13 minus 10, my other two sides. I get 3. That's my shortest. Right? And then I'm going to add them. 13 plus 10. That's my longest. All right. 22. Is it bigger than 3? It's got to be between 3 and 22. So bigger than 3? Yes. Less than 23? Yes. So this could be a triangle. So yes. The other one was no. Last one. 14, 8, and 6. I'll take my longest side. That'll be my third side. I'll use the other two as my shorter side. So 8 minus 6 equals 2. And yeah, I always subtract the smaller one from the bigger one. Otherwise, I'm going to end up with a negative number. 8 plus 6 equals 14. So the shortest it could be is 2. The longest, it's got to be more than 2. And it's got to be less than 14. It is 14. Could these be the three sides of a triangle? No. This is the harder case, right? Because the only way that third side could be 14 is if I had them laid out going in opposite directions. So that the angle between the other two sides, the side that's 8 and the side that's 6, is 180 degrees. And if I have that, I don't have a triangle. Okay. So that's the triangle inequality.